scientific aid. As Gause introduced his own method of solving linear simultaneous equation, the Jordan now say there is another form that should be attached to the joint to the Gause method to make it the Gause and Jordan elimination rule. That means Gause started the work and Jordan finish up the work. Then you cannot, if you are stating it or you are documenting it, if you are making a documentation, you cannot just say that the work was done by Gause alone or the work was done by Jordan alone. You have to put them together based on the rule of report, that is the principle of reporting and issues. Therefore, it's Gause and Jordan that put hands together. If you can do your Gause very well, the Gause and Jordan will not be anything, will not be difficult for you. Now let's do the Gause and Jordan. You first of all, as we did for the Gause, 4, 2, 12, 3, x, y equals to 16, 7. Now divide row 1 by A11, which is equal to 4. This is our row 1. 4 comes first, 4 all over the 4. 12 all over 4. And 16 all over 4. Which row 1 will be equals to 4 all over 4, 1. 12 all over 4, 3. 16 all over 4, 4. This is your new row 1. So now get your matrix like this. You get your matrix. In place of row 1, you put 1, 3, and 4. 1, 3, x, 1 equals to 4. Your row 2 should be the way it is, 2, 3, 2, 3, and 7. You now get your new row 2. New row what? 2. Which is equals to row 2 minus 2 row 1. Row 2 minus 2 row what? 1. What is our row 2? You now first of all simplify your 2 row 1. 2 row 1 is equal to 2 into our row 1 is 1, 3, 4. Therefore, our 2 row 1 will be 2 times 1, 2. 2 times 3, 6. Then 2 times 4, 8. 2 times 4 is what? 8. This is our row 2 row 1 now. You now say to row 2. Therefore, the expression of row 2 minus 2 row 1 will be now put your row 2, that is substitute this row 2 by the normal row 2. You say row 2 is 3, 2, 3, 7. Let's come down a little. 2, 3, 7 minus 2, 6, 8. 2, 6, 8. Therefore, we now see row 2 now. New row 2 will be 2 minus 2, 0. 3 minus 6 is minus what? 3. Then 7 minus 8 is minus what? 1. You now generate your new matrix. This new matrix is where you are going to put your new row 1 and your new row 2. That is why we call it new matrix. What is our new row 1? 1, 3. 1, 3. Then x equals to 4. What is our new row 2? 0 minus 3. 1 equals to minus 1. If you look at it, this is known as Gause matrix. This is the matrix that we use back substitution to get the value of y and x. If you stop here, you have obtained Gause matrix. Now we are going to proceed by the Jordan. Even without saying, you know that Jordan just attached his own terminologies or his own techniques to the Gause method. That is why, since he used the Gause method first, this is where the Gause method stops. And what we are going to join now is the Jordan principle. That is why we call it Gause and Jordan principle. What does Jordan principle say? Jordan now says the matrix should be converted into identity matrix. That is, The leading diagonal should be 1, 1, and the other should be any number. Now you now say you are using this now to make the number above the 0. Before we use this to make this 0, we are now going to use this to make this 0. Since it is minus 3, you say divide row 2 by A22. What is our A22? Minus 3. Our A22 is minus what? 3. Row 2 now is 0 all over minus 3, comma, minus 3 all over minus 3, and minus 1 all over minus what? 3. Therefore, our row 2, 0 over minus 3 is 0. Minus 3 divided by minus 3 is 1. Minus 3 divided by minus 3 is 1 all over 3. 1 all over what? 3. This is our new row 2. New row what? 2. You now come, you take this matrix, you open the matrix like this, 1 and 3, 1, 3, row 2, here don't forget is 0, here 1, x, y equals to 4, 1 all over 3, 1 all over 3. Now we want to get our new row 1. Our new row what? 1. You now see new row 1 will be equal to row 1 minus 3 row what? 2. With 3, this 3. Row 1 minus 3 row what? 2. Since it is this 3 we want to make 0, that is why we put the 3 here. Therefore, our 3 row 2, our 3 row 2 will be equal to 3 times row 2. Where is the row 2? Here is the row 2. 0, 1, 0, 1, then 1 all over 3. What will be our 3 row 2 now? 3 times 0 is 0. 3 times 0, 0. 3 times 1, 3. 3 times 1 all over 3 is 1. This is our expression for 3 row 2. 3 row 2. Therefore, row 1 minus 3 row 2. Where is the row 1? Row 1 is here. Therefore, our new row 1 will be equal to row 1. Where is our 1? 1, 3. 1, 3, column, what? 4. Minus 0, 3, 0, 3, column, 1. Our new row 1 now will be 1 minus 0, 1. 3 minus 3, 0. Then 4 minus 1, 3. You now generate your new matrix. This matrix comprises the new row 1 and the new row 2. Our new row 1 is 1, 0, 1, 0, x, y, 3. Our new row 2 is 0, 1, 0, 1, then 1 all over 3. If you look at it, if you say 0 times x is 0x plus 1 times y. Okay, yes, 0 times x is 0x plus 1 times y is y equals to 1 all over 3. 0x is eliminated. Your y equals to 1 all over 3. If you come here, 1 times x is x. And 0 times y is plus 0y equals to 3. Equal to what? 3. Therefore, your x will be equal to, because this y times 0 is already 0, your x will be equal to what? 3. Therefore, the same thing, our y equals to 1 all over 3 and our x is equals to 3 using the Gause elimination theory. Using the Gause elimination what? Theory. Now, if you have the knowledge of using the Gauss and Jordan elimination theory, this solution is Gauss-Jordan elimination rule, while the previous solution is Gauss elimination rule. As we told you, based on the principle of report, if a person starts a work and if Mr. A starts a work and Mr. B finish up the work, you cannot just say the work was done by Mr. A alone or the work was done by Mr. B alone. Based on the principle of report, you have to join both names together. As God started the work, if you look at it, all the step here, from here up to this, is God's method. From step 1 here up to here is God's method. And from here up to there is the Jordan method. By joining these two methods together, we call it the Gauss and Jordan principle. If you follow it very well, Gauss now made use of, Gauss is just like having a triangular matrix, while the Gauss-Jordan is just like converting the given matrix into an identity matrix, where the leading diagonal should be 0, or identity matrix where all other parameters in the matrix should be 0, except the leading diagonal, which should be 1, 1. This is the Gauss and Jordan principle. As time goes on, we will continue giving you the suitable method for solving linear simultaneous equation. Here, don't forget